Welcome to the Automate workshop. Hi, I'm David. Diagnosing a fault in vehicle wiring can be challenging. Finding its location can be downright difficult. Once found, it needs to be repaired. In this module, we'll look at some of the best practice repairs. Let's start by having a look at some of the tools required. Removing the insulation or stripping the wire can be done in many ways using various tools. Using pliers or side cutters is not one of the recommended methods, as this can damage the insulation or the wire itself. It also puts quite a bit of strain on the conducting strands. It's possible for some of the conductors to break. This is a concern, as the cross-sectional area is now smaller, reducing the current carrying capacity of the wire and increasing its resistance. These strippers are commonly used in the automotive industry, but they would not be my choice. If we have a look at a couple of examples, you can see that they're not all the same. With the cheaper ones, it is possible to damage the wiring or the insulation. This type of wire stripper does a good job, provided they're adjusted correctly. If adjusted too tight, then the wire can be damaged. Set too loose, and the insulation may be damaged or excess strain placed on the cable. They have an advantage of being able to get into tight places. The same applies to these. Proper adjustment is critical for correct operation. Here is one of the auto-adjusting types of wire strippers. Simply place the wire in the end and squeeze the handle. The advantages are that you don't have to keep adjusting the strippers for each different size wire. They put virtually no strain on the cable and are great for confined spaces. They can, however, damage the insulation on larger wires. These are also auto-adjusting wire strippers, with similar advantages to the previous ones. Adjustment is provided to vary the clamping force on the wire. These strippers could also damage the insulation on larger wires. This one, although not automatic in its adjustment, does a very good job. It cuts the insulation down to the wire level, thus reducing the strain on the cable when removing the insulation, and does not damage the insulation in the process. Care needs to be taken to ensure that the correct wire size opening is used. This will prevent damage to the wire itself. My personal preference for most applications are these. Again, they are not auto-adjusting, but like the previous ones, they cut the insulation all the way round, reducing the strain on the cable and damage to the insulation. The limitation they have is the size range of the wire they can accommodate. A tool to cut the wire is a necessity. Side cutters, sometimes referred to as diagonal pliers or diagonal cutters, are the best for this job. You can use a pair of normal pliers or any pair of side cutters, but these are often too big and don't leave an ideal finish. Precision side cutters with a flush cut blade are the best to use. They make a clean cut with no wire strands being exposed. Because of the flush cut blade, you can cut and trim wiring extremely close. These side cutters should be kept for wiring repairs only, to keep them in good condition. Repairing broken wires can be done in several ways. One of the methods uses a joiner often called a Scotch lock. These are quick to use but have some drawbacks. They work by piercing the insulation and making contact with the wire. If the wire has a large cross-sectional area, then there is a chance that the conductor may be damaged. If, on the other hand, you use a small wire, then it may not make good contact. Another downside to these connectors is they're not weatherproof. Any moisture getting in will tend to stay there and create oxidisation problems. If any force is placed on the wire, it is possible for the wire to come out. These connectors work on the same principle, but have a sealant that is injected into the joint, making it weatherproof. They are mainly used on single-strand wire. Crimp sleeves are a common type of wire repair. If used correctly, these connectors produce a good result. The key to getting a good connection is to use the correct crimpers. Crimpers, just like wire strippers, come in many different types. This type is from the lower priced end of the range. The crimper jaws are colour-coded for the different terminals: red, blue and yellow. The problem with this type is that there is no indication when the crimp has provided enough clamping force. I'll demonstrate. To ensure the correct crimping force is used, I'd recommend ratchet crimpers. These ensure that the correct force is applied to the connector and is consistent each time they are used. They also require much less effort. This is an advantage if many connections are to be made. These connectors form a strong joint, but they're not weatherproof. If you require a connector that is weather resistant, you would need to use a heat shrink crimp connector. These are often known as Duraseal connectors and are available with glued and non-glued heat shrink. There are many ways to activate heat shrink. The best tool to use is a heat gun. This connector uses glued heat shrink, creating a wire joint that is completely weatherproof. As with all crimp connectors, it is possible to pull them apart because they only rely on the friction of the crimp sleeve to hold them together. There are solder heat shrink connectors. These have the solder inside the connector. The wires are fed in from each end, making sure they overlap, and simply heated with a heat gun. You can, of course, solder two wires together without using a connector, but there is a right way and a wrong way to do this. When we're soldering, we should use resin cord solder. This helps the solder flow into the joint better. We apply the soldering iron to the joint and then apply the solder and let it flow in. If you do it the other way and apply the solder to the iron first, you'll see that it doesn't want to stick because there's no flux. I have two wires twisted together. I'll just solder them. And there we have a good electrical connection. The problem is that it's pretty bulky. And one other thing, it's not very strong. If we twist the wires this way by crossing them over and twisting them around each other, we get a very neat joint. And if I solder this joint, you'll see I get a very good electrical connection. Plus it's really strong. And if I add a bit of heat shrink to it, and you've got a wiring joint that is no bigger than the original wire. If a harness needs repair, you can use heat shrink tape. This tape is wrapped around the harness and secured with cable ties. It's then heated to shrink the tape and activate the adhesive. When cool, it will provide a solid and secure cover. Remember, when doing any repairs with heat shrink, you need to protect any adjacent wires or components. This can be done by using an aluminium shield behind the wire repair. Repairing connectors is sometimes necessary. These repairs normally use non-insulated terminals. You should use the correct crimper for a good electrical connection to be made. Even though this crimp terminal should be okay, I still prefer to add a bit of solder. Some wire repairs require special attention. CAN bus wiring can be repaired, but the twist in the wire must be maintained to help eliminate interference. Many oxygen sensor pigtail wires cannot be repaired, as doing so will cause a problem with the sensor. Supplemental inflatable restraint, or SIR system, is another area that requires special attention. It is necessary to follow the manufacturer's instructions for the SIR system to maintain its integrity. There you have some of the suitable methods for wiring repairs on modern vehicles. Always remember to follow the manufacturer's procedures. Take your time and do a proper job. And remember, training is the key to your success. Bye for now.